Okay guys, we're going to talk about a discrete random variable. This variable has a fixed set of possible values in contrast to the continuous random variable. What we do is we assign each value a probability between 0 and 1. And what's nice about discrete random variables is the sum of all these probabilities add up to 1. Alright, a continuous random variable. This variable will have an infinite amount of values in an interval of numbers. It also will have a probability distribution that can be described by a density curve. As you will see here, this density curve will have an area underneath the curve equal to 1. And this is convenient for figuring out probabilities within this distribution.
From all that we went through, and I took a troubled track.
A binomial random variable is when we're looking for the number of successes in a fixed number of trials. The actual number that we'll get is the probability of actually getting those number of successes. Now, if we look in the bottom left of the screen, we'll see mu equals n times p. Mu is the expected count of what we'd expect our number of successes to be, given n, our total number of trials, and p, the probability of getting a success. We'll compare the expected value to the value that we get from our binomial test. And sigma is the standard deviation of this trial.
Okay, so we're going to talk about geometric random variables, and it is the number of trials until the first success. And there is no fixed number of trials. So an example of that could be, how many flips of a coin until I get a heads?
Okay, so a great way to distinguish between a geometric and a binomial situation is the number of trials. If it's specifically laid out that you're going to take 50 rolls of a die, it's going to be a binomial situation. Or if it's, you want to see, like in the last slide, how many flips of a coin until I get a heads, we don't know if it's going to be 10 flips or 50 flips that we get a heads. Okay, means are also called expected values. And when we're looking at graphs, we call it the balance point. So if you look down at these two examples, the one on the left is pretty much centered, so the balance point would also be centered because the weight would be distributed evenly. Now if we look to the right, this graph is skewed to the right because its tail is on the right side, which means that it's heavier on the left side per se, so that means the balance point needs to be shifted more to the left. So to find the mean of a discrete random variable when given a table of values, we're going to input each list into a list on our calculator. So we're given this example, cars sold versus the probability, and for each one of these, we're going to take the values of the cars sold and put them into list 1, and the probabilities of each one of those events into list 2. Then we can go to our calculator and input them into the 1var stats function, and will be outputted a mean and a standard deviation.
Alright, so assuming this is what we were assigned, this is transforming data. And as you can see by this chart, there are a few things that are affected and are not affected as we multiply, divide, and add and subtract. So, as we add and subtract, the center is affected, as you can see, but the shape, there's no change. And the spread, there's also no change. Then as you multiply and divide the data, the center is altered as well. There is again no change for the shape, but the spread, there is a change. And that's the only difference, I suppose.